Cluster computing architecture actually it happened. Let me scroll it up. Goes like this. Here you can see that terminal 1, terminal 2, terminal 3 up to terminal n number of different terminals are connected to one another using some networking technique. However, you should not think of this a ordinary set of computers connected via some network, which we usually see in our college laboratories. Rather, the user will perceive this is server 1, server 2, something like this, and this is uh, public which are accessing this computational system, and user at this end will perceive as if a single unit of computer he or she is accessing, and this is the main feature of this cluster computer architecture. So when you will explore the different facets of this architecture, then the architectural goal or the goal behind this design will be more clear to you. So here are some of the features of cluster computer. Let we go through them one by one. All the connected computers are the same kind of machines, and one thing I will like to add to this point is that they are basically individual standalone machine, or they can act as individual machines. So these different terminals, n number of terminals, which you can see in this diagram, are basically same kind of machines. Next point, they are tightly connected through dedicated network connections. So you can see in the diagram that they are indeed connected with one another, and this connection or networking technology is a salient feature of this cluster computer architecture, and all the computers share a common home directory. That means if you think of the memory of this cluster computer architecture, then you can see that they basically share a common home directory. This directory, the diagram is being shared by all the n terminals in the cluster computer architecture. So there are different hardware configurations possible, and this hardware configuration difference is based on the selected networking topologies. Now, cluster is categorized as open and closed cluster, wherein open clusters, all the nodes need IPs, and those are accessed only through the internet or web. So you can think of this with an example. Say you are going to use the Google Web Services, or Google Web Services, or more specifically it is termed as Google Cloud Services. So basically what we call or term as cloud, how this is implemented, if you think of this a little bit, you can figure out that in Google's office, what happens, there are basically n number of computers which are dedicated, say, for our Google Drive operations. As they are hosted in cloud, or the interface between you and the Google is what we call cloud computing structure, you have to access the cluster computers which has been hosted by Google using some IP and internet or web. So in this case, basically the cluster computer model is open cluster model. Now, obviously the problem which comes with this is as you are accessing everything via web. This type of clustering causes enhanced security concerns. This is obvious. Whenever you access something over the web or internet, added security concerns are always there. Now, let me look into closed clustering. In closed clustering, what happens? The nodes are concealed behind the gateway node and they offer increased protection. That means it is something which you don't actually uh, access to the internet or web, rather it is accessed via something called intranet. That means in an office premise, say, all the computers are connected via some networking device to act as a cluster computer, which can be accessed only by the persons who work in that office through the intra-networking which has been implemented into the office. And in that case, we will term it as closed clustering. So, types of clusters. So, here you can see different types of clusters which are possible. Let me go through them one by one. Computer clusters are arranged together in such a way so as to support different purpose from general purpose business needs such as web service support to computation intensive scientific calculations. Nowadays, you can see that different web services are there which we can use in our day-to-day life, such as Google Drive, when we have what we call it spreadsheet operations in Google. Another thing we are using for this particular subject also, Google Classroom, which is nothing but a web service support. So these services are accessible by naive users or common users like us because of this cluster computation. And this is not actually limited to this kind of web service support. This idea can be extended to computational intensive scientific calculations also. A simple example of this is nowadays you can access the what we call it online compilers. So using those online IDs and compilers, you can run your computation extensive scientific programs also. You don't need to run them anymore onto your local computer. You can run them onto the cloud directly. So this is basically the spread of cluster computers. You can see that the spread is basically huge one. There are three types of clusters. They are load balancing cluster. So basically what happens here is that a cluster requires an effective capability for balancing the load among available computers. So in this, what goes is cluster nodes share computational workload so as to enhance the overall performance. For example, a high-performance cluster used for scientific calculation would balance load from different algorithms from the web server cluster, which may just use a round robin method. This is an example. Don't go for the turn by assigning each new request to a different node. This type of cluster is used on forms of web server, web form. So what actually it says is that, again, let we revisit our previous diagram. Here you can see that you have n number of terminals into your cluster computer architecture. Now, just imagine for a moment what will happen if all the load or computational load is put onto the terminal 1 itself. What will happen? So you can think that with extra load, extra load, extra load every second, if put onto this terminal 1, it is going to crash after some time. So what is the solution? Just split the load equally among the different terminals so that there are some kind of load balancing happen here. So this was the idea behind load balancing cluster. So next one is failover cluster. The function of switching applications and data resources over from a failed system to an alternative system in the cluster is referred to as failover cluster. These type of clusters are used to cluster database or critical mission mail, file, and application servers. Why? The question obviously arises here, because you can see that when we say database or email or mail server, application server, then the first thing which came to our mind is backup. Say you have a database somewhere. So the question obviously arises in our mind is that what will happen if the machine onto which our database is stored is crashed? What will happen? In that case, you see backup systems become important. So how this goes, like, say somehow during its computational life, terminal 1 crashed. So the content, whatever is there into terminal 1, will also lost with the crashing. You need a backup mechanism by which when it went off, you can translate everything, whatever was there into terminal 1 to other terminals efficiently. So in this case, this failover clusters become important, which is basically an alternative system for the failed resource. Last one is high availability clusters. These are known as high availability clusters because they offer a a high probability that all the resources will be in service. If a failure does occur, such a system goes down or a disk volume is lost, then the queries in progress are lost. Any lost query, if retired, will be serviced by different computer in the cluster. This type of cluster is widely used in web, email, news, or FTP servers. Again, these two seem similar, but there is some subtle difference. And where is the difference? The difference is somewhere here. Let me visit our first diagram once again. Uh, in failover cluster, you see our main idea was the translation of the content from the failed terminal, say for example terminal 1 to other terminal, right? So you need to translate the contents from failed terminal to other terminals in failed over clusters. But in high availability cluster, the perspective is from the user's standpoint. Say user is here. For example, it is you for the time being, and you are using your Gmail account or Facebook account. Now, the behind the scene content is that your Facebook account is basically hosted somewhere or in some machine into the cluster, right? Say for the time being, your Facebook account is hosted in terminal 1. So what happens is that from remote machine you are accessing your Facebook account through this cluster computer architecture interface. Now, when you are accessing your Facebook account, if this machine goes down, what will happen? You see, instantaneously everything will go dark. And from our day-to-day experience of using computers, we know that computers as a whole are failure prone. But just try to recall, since you have started using Facebook, for how many times it has gone dark? Might be never. This is because here somewhere there must be a mechanism by which the content flow is perennial. By perennial I means it is like a river which flows throughout the year. It never goes dry. So if this machine goes dark or this machine fails, then the content will instantaneously flow from other backup system. And this transition time means from the failure to flow of content from other different machine will not be perceived by the user. And this is the idea behind this high availability cluster. Now you can find the justification of this line. Yes, this one. If a failure does occur, such as a system goes down or a disk volume is lost, then the queries in progress are not lost or lost. Any lost query, if retired, will be serviced by different computer in the cluster. You can see, as we have discussed in our example, if this connection is lost due to the failure of this terminal 1, then your request will be serviced by a different node, that is terminal 1, into the cluster. This was the idea behind high availability clusters. Now let we move to some of the benefits which have been achieved by the introduction of cluster computer architecture into the industry. First one is absolute scalability. It is possible to create a large clusters that beat the power of even the largest standalone machines. A cluster can have dozens of multiprocessor machines. Now, to realize this point, you need some kind of imagination. Just give the idea some thought. How many processors you can embed into a multiprocessor machine? So you will say that I can embed 8 processor, octa-core processor, 16 processors, 64 processor architecture. Say 128 cores are there in a single processor. You can think of like this. But they will always be the standalone machines. Now, the cluster computer architecture is always one step ahead of our those so-called standalone multiprocessor machines. Why? Because those standalone multiprocessor machines can be included in a cluster computer architecture. Say your terminal 1 can be a octa-core machine. Your terminal 2 can be a octa-core machine, and so on. Now, extend the idea a bit. Say our terminal 1 is a 128 core processor machine. So you can obviously embed n number of 128 core machines into your cluster computer. So as you increase the number of cores in a single processor, single MIMD processor, the cluster computer architecture in terms of computational capability will always be one step ahead because of this absolute scalability feature. Because each and individual machine can be a high performance MIMD architecture machine, which you can think of. Next, additional scalability. Additional scalability goes like a cluster is configured in such a way that it is possible to add a new system to the cluster in small increments with little cost. Clusters have the ability to add systems horizontally. This means that more computers may be added to the clusters to improve its performance, redundancy, and fault tolerance. The ability for a system to continue working with a malfunctioning node. Give it some thought. Now, you can add an extra terminal to this horizontal architecture, say terminal n plus 1 with little cost, right? You can obviously think of it. Now, next advantage which this additional scalability point offers you is that the ability for a system to continue working with a malfunctioning node, which we have discussed while we were talking about this load balancing cluster and not load balancing, sorry, failover clusters and high availability clusters. So in fail availability clusters, we had discussed about, say, what will happen to the contents of a particular terminal if it fails. It can be translated to another terminal, and high availability cluster, somehow while terminal 1 is serving the request of user, if it goes off, what will happen? The flow of data or computational task will be done by some other terminal into the network. So this is basically the additional scalability feature which is being offered by this cluster computer architecture. High availability. As we know that each node in a cluster is a standalone computer, the failure of one node does not mean loss of service. It is obvious. From our previous discussions, we know that. You can see what will happen. Just think, if a particular machine goes off, nothing. The entire computational task can be done by using the remaining terminals or remaining nodes into the architecture. So this is basically high availability. The user of this cluster computer service will not be able to understand when a node fails. So a single node can be taken down for maintenance while the rest of the clusters takes on the load of that individual node. This is, in my opinion, is the highest benefit of this cluster computer architecture. You don't need to turn off your entire system for maintenance. As you know, maintenance cost in terms of time, in terms of money, is huge. You don't need to turn off your service, you don't need to disrupt your service for maintenance purpose. Because whatever computational service a particular node is going to offer can be served by other nodes while you will maintain this terminal one. Last one is preferable price over performance. Clusters are usually set up to improve performance and availability over single computers. And this point is obvious from whatever we have discussed until now. As you have n number of nodes, multiple number of nodes into your system, obviously performance will be increased. Some instances of performance increase we have observed in terms of high availability and failover. These are obviously, this high availability and failover concepts are improvement of performance. So you have improved performance here and availability over, yes, and it is obviously going to be cost effective. Why? Because to improve the entire architecture, what you have to do, you have to add some additional nodes to your clusters most of the time. Now you can see that to add some additional nodes, you don't have to do much. When you say you are adding additional nodes, basically what you are doing into your network, you are adding an extra standalone machine. That's all. Nothing more than that. So it is obviously much more cost effective than single computers with respect to comparable speed or availability. You can think of a computer which can give you the performance which is being provided by this cluster computer with n nodes. You can think about the complex circuitry that will be necessary to implement this thing. So with respect to that standalone computer which is capable of, which will be capable of providing this much of computational effectiveness, the cost is going to be much lower for this cluster computer. So this was the basic concept behind the cluster computer.